So let me start then. So thank you, everyone, for having invited me. It's a pleasure to be here, even though, of course, in this way I don't get to enjoy the charms of Barcelona, and I won't have a chance to have a prolonged exchange with you, which is unfortunate, but maybe there will be some other occasion. I'm going to present today a project I've recently been working on, as you can see from the title page, with Vincent Lam, who has been a collaborator of mine in the past. And it's part of a bigger project I'm engaging with that I will present in a bit more detail once we get there. As you can see, this is going to be more philosophical rather than digging into the details of the physics. It's not a talk in the foundations of physics, but it's something that is going to explore a bit what I take to be philosophically interesting implications, perhaps, or reverberations from fundamental physics. I hope this is appropriate for the group, and you didn't expect me to do some sort of technical presentation in the foundations of physics. If you do have questions about the foundations of the physical theories in the background, I'll be happy to discuss those in Q&A. Okay, so the overarching question that I'm going to be interested is the compatibility of a position in theoretical philosophy and much of philosophy of science, but certainly also in metaphysics, that goes by the name of Humeanism, and a naturalistic approach to philosophy, in particular to metaphysics. And more specifically, I'm going to ask a question whether these two positions, Humeanism and naturalism, are in fact compatible. More specifically, can one be a Humean about laws of nature? So this is Humanism about a particular subject area, if you want, and at the same time be a naturalist in the sense of starting out your inquiry from fundamental physics. The thesis I'm going to argue for, or going to at least illustrate and hopefully give some support to, is the idea that looking at fundamental physical theories beyond those which are empirically established, namely the standard model of particle physics, that's sort of the most sophisticated, most advanced theory of quantum physics, on the one hand, and general relativity as our best account of space-time and of gravitation on the other hand. If we do that, this suggests that there is a novel and, in fact, much deeper naturalistic challenge to Humanism about laws of nature than any of those that have been debated before. The principal problem that arises when we look at those two, sort of this combination of fundamental physics with a Humean approach to understanding laws of natures, is that it's not even clear how to articulate such an account of laws in a world that is, as we will see, fundamentally non-spatiotemporal. That's going to be the central problem. Now, you might think, hang on, what was that? The space-time disappears in fundamental physics? Surely, you might think, with Larry's Clark, how could possibly anything be a more essential, a more ineliminable component of our conceptual framework than that ordering of phenomena which places them in space and time? I mean, for those of you who know the history of philosophy, and I take it there's at least some of you who do that, because the PROTEUS project has also a historical component in ancient philosophy. And if you don't look maybe to Plato, but to Aristotle in ancient philosophy, to be for Aristotle really is to be in space and time. So that the very notion of existence, of what it means to be some material physical object or structure is to be in space and time. And certainly many philosophers, if they haven't articulated this explicitly throughout the ages, they have implicitly assumed this to be the case. So Clark continues, we could imagine a world without electric charge, perhaps without the atomic constitution of matter, perhaps without matter at all, but a world not in time, a world not spatial, except to some Platonists. Now here, I'm actually, I think this is not quite accurate. This should probably be something like to some Pythagoreans, because Plato, as far as I know, doesn't deny that the world could be doesn't say that the world could be or is non-spatial and non-temporal. But anyway, such a world without space and time would seem devoid of real being altogether. Now, the problem is that when we look to quantum theories of gravity, as you may have encountered as well, because another part of PROTEUS, from what I understand, is to look at exactly the implications of fundamental quantum theories of gravity as they have been proposed or sketched out, is in fact that there is no space-time fundamentally. Either this is a postulate right from the beginning of a theory, or it's an implication. And certainly the denial of space and time being fundamental comes in degrees. So there are some theories of or approaches to quantum gravity which are more spatiotemporal than others. Others postulate degrees of freedom which are completely different from those we would accept as spatiotemporal or normally assumed to be spatiotemporal, and others seem to be closer than that. And in some approaches, it seems time that seems to vanish, but not space. In others, it seems more like space is vanishing, but not time. So there's a whole, sort of varied landscape of different options here. And the result really depends quite sensitively on the approach taken. But nevertheless, we see similar things happening in many different approaches. And if that's right, then in the language of physics, we could say that space-time theories like general relativity, which you can understand as a theory about space-time, of course, that theory would become an effective theory as opposed to a fundamental theory. And the entity which it describes would be emergent rather than fundamental. You can think of analogies such as thermodynamics or hydrodynamics being effective theories like this. These are not fundamental physical theories. These are theories which can well describe certain phenomena at an effective level, which deal with quantities such as temperature, for instance, in the case of thermodynamics, as an emergent property or physical state, or something that could be attributed only to emergent states of the fundamental physics. And similarly, maybe the liquidity or flowing properties of a liquid, of hydrogen, liquid hydrogen, for instance, of water flowing, would be an emergent phenomena. And of course, in the case of thermodynamics, we think that it's something like the collective behavior of the gas molecules, perhaps, that would be the fundamental of physical theory, and maybe the statistical generalizations then are what gives rise to the effective theory. Okay, so in general, the emergence of space-time in this sense is physically contingent in the sense that it can fail under some circumstances. Very much like some gas molecules could fail to have a well-defined temperature, or that hydrogen atoms or water molecules could fail to have some sort of well-defined flowing properties. In fact, sorry, that was the wrong scene. I have to admit people who are coming in, which undid this. Okay, anyway. So one nice way to understand this is by using Daniele Oritti's level of space-time emergence. He has proposed, hi Daniele, he has just in time, he has proposed to understand the emergence of space-time as varying in kind in a way that could be understood as different levels. These are not levels in the sense of strictly ordered or one level implying another level or something like this. This can, in some sense, are kind of orthogonal levels that can be combined in different ways. But at what Wüthrich says is level 0, you could understand GR in a way that certainly already offers a structure, describes a structure that's not quite like the pre-relativistic space-time, and you can quantize the degrees of freedom that are identified by general relativity, which are geometric degrees of freedom. So in general relativity, of course, space-time is understood geometrically. So you can quantize these geometric degrees of freedom, and you can have a quantum theory in some sense or other. Oritthi helpfully gives us analogies to the hydrodynamical situation. So here, for instance, you understand the degrees of freedom, you understand the phenomena to be a liquid flowing, saying, and the relevant equations to be something maybe like Navier-Stokes equations or equations describing the phenomena at that level. In order to get back to the previous theory or to the theory which doesn't have any level of space-time emergence, you take the classical limit to get back from the quantum theory of geometric degrees of freedom. You get back to the classical theory. At level 1, you can then say, no, we need to go further because the fundamental degrees of freedom are not quite the geometric degrees of freedom identified by general relativity, so we cannot just straightforwardly quantize those. In fact, what we do have is more something like a combinatorial or algebraic structure. You can think in the hydrodynamical analog that this is a discrete, you recognize that the structure you're looking at is not a fluid in the sense of Navier and Stokes, but instead what you have is discrete, a bunch of discrete molecules which give rise in some sense at some scales to the phenomena you have identified beforehand. And here you have to, in order to get back to the fluid continuum, you have to take the continuum limit. And that's distinct from, but sometimes confused with, taking the classical limit. So you can have a classical theory here, which, however, is a discrete theory, and you then need to take the continuum limit, of course, to get back to the continuum theory. Anyway, now in the case of a hydrodynamic system, of course, you can have the same kind of degrees of freedom, in some sense, the same kind of system present, but that system can be in different phases. I mean, this is very clear here. This can be a liquid, gaseous, or solid phase, of course. Now, in the case of space-time, it may be that some of these phases are non-geometric, that some of these phases really show very different behavior from the geometric spatiotemporal behavior. And if that's the situation, then what you have to do is you have to show that there exists at least a phase or several phases in which you have something like space-time or geometric degrees of freedom emerging. At the final third level, you can then also think about phase transitions. Of course, in a hydrodynamic system, you can have phase transitions if energy is taken away or introduced into the system. You can have a phase transition, for instance, or if some of the other quantities change, that can lead to a phase transition as well. And in a sense, you can then think in this case of space-time, that you can have a transition, as it were, from something that is not space-time, from something that is very different from geometrically understood space-time to space-time, to something that now has geometric degrees of freedom, that is a geometric face, sort of a spatiotemporal face, if you want. Wüthrich calls this geometrogenesis. But of course, the transition is not a transition in time, because time itself only really emerges as a result of such a transition. So the challenge here is to understand what it means to have these phase transitions in the absence of time and an ordinary understanding of dynamics. Okay, now this is rather abstract. I haven't given you really much of a detailed quantum theory of gravity to show how this could play out. And that's not what I'm going to do today. Instead, I'm just going to tell you that it's really a much bigger general project I'm pursuing with Nick Huggett to understand emergence of spacetime in various specific approaches to quantum gravity, and what it means to have degrees of freedom that are less than fully spatiotemporal, what the emergence of a fuller spacetime could mean, and so on and so forth. What I'm going to do today is, in a way, a much more specific sub-project with Vincent Lam, in which I will try to work out the implications of this for analyses of laws of nature. We have a paper which is almost ready for submission, on which this talk is based, or at least on my part. Okay. Again, I'm not entirely sure. So there are some I know in the audience, but not everyone. So I'm not 100% sure what the background is. But to give you a very quick introduction, if you want, to laws of nature, in the philosophical analysis, trying to understand what laws of nature are, there's two big families that could be distinguished of approaches. And one is the Humean approach, and the others are the non-Humean, I suppose. There is not really a better name. Some people call them the anti-Humean, and in the sense that they explicitly distinguish themselves from a Humean, I guess you could call them anti-Humean, but I like to be a little bit more neutral here and just call them non-Humean. All right, the basic idea of a Humean approach is that particular states of affairs, particular occurrent facts, these are contingent facts, and they're particular facts. They're normally understood to be local facts. I'll say a little bit more about what these are. That's what's fundamentally there. And it is those facts, the totality of those facts, which determines what the laws of nature are. So the determination relation is from the facts to the laws. It's the facts which determine the laws. The laws, in turn, summarize the facts in some sense. Maybe they do this by describing salient patterns that we find in the facts. Salient sort of generalities, more general truths about the facts. And in that sense, they offer a summary. For a non-Humean approach, this relationship is inverted. You start out from the laws of nature, which are in some sense prior to the facts, in the sense that they are what determine how the facts turn out to be in a world, how the facts come to be. That's the sense in which the laws of nature are thought to be governing the particular states of affairs. And those states of affairs, those facts, are therefore secondary to the laws of nature in the sense that they obey or observe, or in some sense have to follow the laws of nature. Okay, that's the two differing fundamental intuitions from which different approaches to laws of nature start. And I'm going to present a little bit more detail here to three different approaches one in the Humean camp and two in the non-Humean camps, because that's the three approaches that we study in the paper we're writing. So on the Humean side, which is what I will be focusing on today, the most important approach is the so-called best systems analysis. So I'll say for each of these approaches what the approach takes there to be fundamentally and what laws are then supposed to be. So as far as the best systems analysis is concerned, which goes back to John Stuart Mill, finds further articulation in Frank Ramsey, and then in the 1970s and 80s in philosophers like David Lewis and John Ehrman and others. The idea is that what there is they're the local matters of particular fact. Lewis calls this the mosaic. I'll say a bit more about this in a minute. So we have a distribution of something like point particles in space-time which have certain properties, which exhibit or exemplify certain properties at the locations in space-time in which they occupy. The laws are then the axioms or the theorems, depending on the formulation of the approach, of what is the best description of that mosaic. Now, what does it mean to be the best description or the best system? It usually means something like finding the best balance between simplicity and strength. And of course, it's not trivial to find a more precise formulation of how that idea ought to be cashed out. But something like this is the general idea. We don't need, so obviously there's going to be criticisms of that approach based on something like, you know, such a balance cannot be had, or it doesn't, you know, simplicity or strength are not objective notions, or something like this. Of course, a whole slew of objections against any part of that characterization. That's much less what I'm interested in today. Okay, good. On the non-Humean side, you can also say the governing conception of laws, we in the paper discuss two approaches. One is primitivism, which assumes, like dispositionalism, which is the other one, that the local matters of fact are something like perhaps the initial configuration of particles in space-time at some moment in time. And then the primitivist adds laws. So laws are something that cannot be further reduced or analyzed because they're primitive posits. You have stuff like particles distributed in space at a particular time, and then you have the laws which govern the evolution of those particles. And these laws are primitive, hence the name of the position. Here, you don't add, so in the dispositionalist camp, you don't add laws, but you add dispositions. The particles have dispositions to act in such and such a way, to follow such and such an evolution, to interact with other particles in such and such a way. And laws really derive from these dispositions which inhere in the objects, for instance, in the particles. So laws are like derivative statements based on those fundamental dispositions. But in both cases, you have a primitive form of modality, either in the form directly of laws or of dispositions, which are thought to inhere in the fundamental objects you posit. Anyway, so in the paper, we do all three. Today, I'm just going to look at the left box here. Okay, so Humean laws in a space-time-less world, how is that supposed to work? And as you can see, in the characterization of what there is, even though not of the laws directly, we assumed there to be space-time here in purple in all of these approaches. So that means there's going to be implications for any of these approaches in some form or another, and that's what we're trying to explore in the paper. Okay, but what are the implications for the Humean approach to laws of
sorry,
nature?
Chris?
Yes.
Sorry, just one question before you move to space-time or less. In the this positionalist account, wouldn't you have probabilistic laws? So although you have these positions as sort of primitive, I mean, existing there as elements of reality, uh, I would imagine that there will be, when you say that, these positions will evolve or change in time, wouldn't you have to admit then probabilistic laws governing this
Mhm.
evolution
Right.
of these positions?
Not necessarily. I mean, uh, so yes, some dispositions are going to be probabilistic. That's often the reason why this was introduced, but not necessarily. They could be surefire dispositions, as it were. Given such and such conditions, the entity, the object, is going to behave in such and such way. Deterministically. I mean, both are options. Of course, in a way, that's the approach welcomes this flexibility of having both kind of dispositions in principle, so that you could, of course, also say that a quantum object for a quantum particle has such and sort, or an atom has a certain disposition, probabilistic disposition to decay radioactively over the next hour or something like this. So that's normally considered an attractive aspect of this approach, that you can have probabilistic dispositions, but it's not necessary that the dispositions are probabilistic. But anyway, it's not what I want to talk about today. I'm going to talk about the best systems analysis. So let's suppose, even though this is not, none of the quantum theories of gravity are established science. They're not textbook science. This is far from it. So these are not often not even fully formulated, completed theories in a way. They're ongoing research programs. But nevertheless, let's suppose for today that this spatiotemporality will be borne out by our first physics. So this is an assumption which clearly, can be overturned by future physics. But let's, as philosophers, look at what the implications would be if this was going to be borne out. So the question is, a Humean analysis of laws of nature viable in a world that is not fundamentally spatiotemporal? That's the central question. And in the thesis, the central thesis of Humean supervenience formulated by David Lewis, which is really at the heart of his approach, we see that this is deeply immersed in an understanding that the world is spatiotemporal. So Humean supervenience is the doctrine that all there is to the world is a vast mosaic of local matters of particular fact, just one little thing after another. So we have geometry, that is a system of external relations of spatiotemporal distance between these points. Maybe the points of space-time itself may be there, so you may be a substantivalist about space-time. Maybe you have point-sized bits of matter or ether or fields or something, or some combination of things like this. That's the basic ontology. And at those points, we have some local qualities, perfectly natural intrinsic properties. This is a technical term for Lewisian metaphysics. We're not going to need all the details of this for today's purpose. But it's important that those need nothing bigger than a point, a space-time point at which to be instantiated. For short, we have an arrangement, a spatio-temporal arrangement of qualities, and that's what there is. There is no difference without difference in the arrangement of qualities. That's the supervenience claim. All else supervenes on that. All right, good. So the supervenience space contains only local non-nomic facts because it's the fundamental base. It cannot have nomic facts, that is, concerning laws of nature. Of course, these are supposed to supervene. What we have is we have these local facts and we have spatiotemporal relations, which are the things which weave all these local facts into a whole. In a way, into a carpet rather than maybe just a mosaic. Really the arrangement, because there are these connections, these spatiotemporal relations between them. So the basic occurrent facts metaphysically precede then all modal and nomic facts. So it's like a sort of a pointillist picture. You can see the trees and the rocks and the boat supervene on the particular local qualities. That is, at each point, the color that point of the canvas has. Right? There could be some differences, perhaps in the color of those dots, without there being much of a difference to the trees or the rocks or the boat. But there couldn't be a difference to the boat or the rocks or the tree without there being some difference in the color of the dots as well. So that's the asymmetry, of course, of the supervenience. Now, a few years ago, and now I see that Giuliano is here, or was at least a moment ago, I think. No, he is. Yes, hi. I gave a talk in Milan based on an earlier paper which has been published finally a year ago, where I argued that this shows that if you assume that a possible world in a Lewisian sense presupposes such a spatiotemporal arrangement of qualities or something like that, then the actual world, if these fundamental physical theories are true, is not even going to be possible. So I'm not going to re-argue for that, but it has certainly implications for the Lewisian system, which would require some reformulation then. Okay, let me skip that then for today. Okay, but now Humean supervenience has been attacked from fundamental physics or philosophy of physics before. People have said very obviously that there's a problem with Lewis's analysis. We have learned from quantum physics, they tell us, that there exist non-local states of affairs. That is, there is a quantum entanglement, which is a fundamental physical phenomenon which does not supervene on local states of affairs. So it cannot be reduced to what this particle's sort of individual state is plus that particle's individual state, because there's an additional fact of the matter as to whether the both of them stand in a singlet or a triplet or some sort of different quantum states. They can still stand in different quantum states even though there's no change to the local states of affairs. So in that sense, that's a supervenience failure and a problem for Humean supervenience. So this is a point that has been made before. People have concluded from this that Humean supervenience may therefore be inconsistent or incompatible with quantum non-locality. Now, Humeans have responded to that and have said, well, yes, it's maybe true that Lewis's particular formulation of Humean supervenience may need a certain relaxation, but this is a relaxation that can easily be accommodated if we include maybe, for instance, in the supervenience space, some sort of known local some additional facts pertaining to quantum entangled states, and then we can still have a supervenience, and that seems in some sense still a Humean base. So this is an interesting problem, but it's not my problem for today, because we accept that maybe the local arrangement, the Humean supervenience space, can be extended to accommodate quantum non-locality. That's, in a way, perhaps that's not in violation of at least the spirit of the Humean approach, which is forbidding necessary connections. I mean, that remains to be seen whether that's really possible. That's an ongoing debate. But what we say is that in quantum gravity, there's a sense in which the challenge runs even more deeply than that from quantum non-locality. If the world is fundamentally non-spatiotemporal, then what it means to be a spatiotemporal arrangement is not even in some sense stateable, because you don't have what it takes to say what an arrangement is if you don't have space-time. There is just no spatiotemporal arrangement in that sense. And the mosaic and carpet metaphors or anything like this are going to be breaking down. The supervenience space, it seems, cannot be articulated. It's not sort of some stuff distributed in space-time if there is no space-time. So now we don't take this to be showing that no Humean approach to laws of nature is possible, of course. But it certainly means the way that Lewis formulated it does not seem to be feasible. Humean supervenience, or whatever supervenience you have, the way in which these laws supervene on the fundamental facts will have to be rethought. We have to ask, what are the particular or current fundamental facts on which the laws are supposed to supervene? Okay. Now, you could maybe ask, why do we need to say that? Why do we need to even articulate what the fundamental, the fundamental facts are on which the laws supervene? Wouldn't it be just sufficient to say that our position consists in whatever is the fundamental, the laws supervene on that, and that's what we maintain, and that's, the physicists may tell us what the fundamental stuff is, and that's it, right? Well, here's where things get interesting, and where I think this points to a kind of tension between Humanism and naturalism that I'm going to try and articulate over the next several slides. In order for a world to be unified and be considered one world, one structure on which the laws can then supervene, the particular contingent facts should require some form of weave or glue, some relations presumably by virtue of which they partake in the same structure. They are part of the same world. They're isolated from other worlds in a sense. For Lewis, of course, it's the spatiotemporal relations which perform that job, but these are not available anymore. So what kind of relations could take over that job? Now, these relations presumably should be external relations in the way that metaphysicians use that terminology. That is, they ought to be relations with which a particular facts could stand in or not as a matter of contingent circumstance. So they're not part of the things themselves somehow. They're not internal to the relata. They are external, and therefore these things are freely combinable with one another in terms of these relations. That's the idea. That's the sense in which external relations are important. So now comes in naturalism. If you're a naturalist, you don't want to say, okay, a priori, these relations have to be those kind of relations, right? No. I mean, this is exactly why, in a way, why Lewis's program failed, because it's a posteriori turned out that these may not be fundamental relations after all, so we shouldn't formulate the fundamental structure in those terms. So in a way, that needs to be determined a posteriori. It's up to our learning from the world. What would presumably be a good model or for these relations? So what a new supervenience space for the naturalistic Humean project might be will then turn on the favored approach to quantum gravity, because presumably string theory or loop quantum gravity or other approaches are not going to be saying the same kind of things will be fundamental. Now, so in turn, this means that what's going to be what's going to be that glue that glues together these worlds will depend on what these approaches take to be their current facts and what connects them in a way. By virtue of what do they exist in the same world, as the spatiotemporal relations in charge of that task before can no longer offer that duty because we've released them into the non-fundamentality, basically. So the connections ought to be assured by external relations, and those cannot be nomic or modal, so because there are no necessary connections in the fundamental structure. That's the Humean demand, of course. Okay, that's what we need to do. So in a slogan, you can say we need some glue to glue together these things into worlds, but we need no nomic voltage. So they should not be nomically charged or modally charged. They should be modally innocent. They should just be, unnecessary contingent things. All right. Now, what could this be? I'm not going to go into this because I'm already running up against time, probably. We did start a little bit late, though, so I hope I can speak for a few more minutes. Okay, thank you. But I do want to give you a little bit of a sense of what that could be. So according to maybe a standard understanding of loop quantum gravity, what there is according to that theory are spin network states. These are discrete combinatorial structures like this, which can be understood as connected networks like this. So that's what's fundamentally there. In causal sets, it's actually it looks very similar on this picture here. They're not quite the same. Actually, these relations are supposed to be causal precedence relation of different sort of fundamental sort of basal events, you could say. Here, these are nodes in a network in a spin network with edges connecting them, weaving them together to one full network. The laws then, in either case of causal set theory or for loop quantum gravity, are the axioms or the theorems, if you want, of those theories which describe these structures. There will be different laws, and I'm not going to tell you what they are, but of course there are statements in either theory which tell you what these things are and how they can combine and how they can form, what the rules are of how you can form structures like this, either spin network states or causal sets. Okay, now an important remaining issue then is what guarantees that these facts are in the basic sets are non-modal or non-nomic. So there's no necessary connections that have been sort of snuggled into the fundamental supervenience space. Because if that's the case, it seems like what we're departing from the idea that the approach is a Humean approach. There are no necessary connections, fundamentally speaking. Now, traditionally, we can accomplish this by having these external relations and then apply something like a principle of free recombination, according to which these elementary entities, such as facts or states of affairs, are freely recombinable in the sense that any combination or permutation generates another metaphysically possible world. There's really no restriction, and in that sense, there's no necessity, because any recombination is permissible, metaphysically speaking. That's the sense in which the supervenience space is non-nomic, is not modally charged, or however you want to express this idea. Now, generally, philosophers do this pre-theoretically. But of course, if you're a naturalist, as I said beforehand, you should look to quantum gravity or some other fundamental physical theory, and those theories should guide us as to what are basic facts and permissible combinations thereof. You can't just do, postulate whatever you want. But of course, I said permissible combinations, but permissible by whom? Well, permissible by those theories in the sense of it accords with the fundamental axioms, the fundamental conditions of what these structures can be in those theories. So in that sense, they are nomically charged. They're not modally innocent. They connect. They have nomically necessary connections in that sense. Okay, so this is how we arrive then at the tension between Humeanism and naturalism. In those theories, these facts are not freely recombinable. They are only combinable in ways permitted by the theory, it seems, right? But to invoke a theory to license permissible recombinations really amounts to in some sense, impose laws on these basic facts and therefore having nomically necessary connections. So that's the sense in which if you want to be a naturalistic Humean, then you have to somehow negotiate that tension within your own position, in the sense that the naturalism doesn't come free of laws of nature in some sense. There are rules, theories, ideas already sort of packed into that naturalistic approach. So you have nomically charged theoretical possibilities that are given to you by the best physics, say, or something like that. Whereas in the Humanism, we cannot accept any necessary connections among the particular facts. The necessary connections are emergent in the sense that the laws of nature supervene on that basis. Or maybe also the laws of metaphysics, perhaps, or any other laws or any other necessity can supervene on the basis, but the basis itself cannot contain necessary connections. Okay, so on pain of some sort of self-defeating circularity, it seems as if the Humean must reject that it is those theories which underwrite the non-nomicity of that supervenience set. And the naturalist Humean therefore finds herself in the awkward position of accepting what our best fundamental theories tells us, what binds particular matters of fact, so that we get the glue of the fundamental supervenience base, without, however, sort of accepting the theory fully or so much so that we get the nomic voltage as well. Somehow you want to avoid that to remain Humean. But the question is there any hope that this tension can be navigated? Is this any way, can this be resolved in any way? Okay, now the next couple of slides, I'm going to explore somewhat superficially two options, which seem, at least if you work in philosophy of physics, I think are natural options. There's no claim here that these are the only options. Surely there's other ways that you could try to navigate this tension. It's just two obvious possibilities. And one proposal that seems fairly obvious is to distinguish between the kinematics and the dynamics of a theory. You could say you take the kinematically possible worlds, that is, those possible worlds or models of a theory which are not yet, which don't have to satisfy the dynamics, that is, the dynamical laws of nature, but could be sets of particle distributions spatially arranged, which evolve in ways which violate the dynamics of the theory, for instance. But they're kinematically possible because the theory tells us the stuff that's out there is, like particles distributed in space, say, or something like that. So that's, in that sense, we could use the kinematically possible models to get us the glue, tell us what the possible world is, but then refrain from imposing the dynamics, and its dynamically possible models then would be the nomological possibilities, because the dynamical laws are the laws of nature. These the dynamics. That's where we get that. So you avoid the nomic voltage in merely kinematically possible worlds. Now it seems if that's successful, that would be pleasing to the naturalist, because this distinction is very much a distinction that physicists are used to make. It's a distinction you find maybe not in all, but in many theories of contemporary physics, and arguably even of older physics in the history of physics. So it stays close to the structure of many physical theories. But there are some difficulties, unfortunately. And here's a list of 3 difficulties. The first one is that it seems to presuppose as I said, a natural distinction between kinematics and dynamics of a theory, but that is a distinction which itself seems to have in the background the idea of something of physics as describing the motion of stuff in space-time or in space over time or something like that, because that's usually what the distinction amounts to between kinematics and dynamics. And if that's true, that's not a distinction that, of course, we can sort of presuppose can meaningfully be applied in quantum gravity. So we have to be careful a little bit here. Maybe there are ways of extending. I think there are certainly some ways of extending the distinction in a somewhat meaningful and justified way, at least to some approaches to quantum gravity. So maybe that's not a sort of a lethal objection here, but nevertheless, it's a note of caution. The second problem is that it may be too naturalistic because it stays in a way so close to a particular framework for articulating physical theories, which is based on such a distinction, that it seems somewhat impoverishing if we would have to think that this already includes the full range of metaphysical possibilities we are to accept. Anything that is not a kinematical possibility of the theory of fundamental physics we're interested in is not going to be a metaphysical possibility. So that's super naturalistic in the sense that it may rule out much of the things that metaphysicians care about. And it may be insufficiently Humean. To what extent, you can ask, you can still say that the kinematic possibilities are not nomically charged. It's true, you haven't imposed the dynamical laws of nature, but why should we only think that the dynamical laws of a physical theory are laws of nature? According to a Humean approach to understanding laws of nature, surely any axioms or theorems of the best description of our theory ought to be counted as laws of nature, including the description of the kinematic possibilities. That is also part of the theory, of the axioms of the theory. What a spin network state is, or what a causal set is part of the fundamental axioms or assumptions of the theory. And in that sense, according to the Humean recipe, it seems like this should be counted as a law of nature. So it's not, seems still building in some maybe weaker form of laws of nature, but still some laws of nature. Here's another proposal, which I owe to Jonas Wächter. He said, what we should, and this is something that ever since then other people have proposed. Look, Chris, they say, you're so focused on actual physical space and physical time. Maybe you just have to abstract away. And the most natural way to do that is when you look at modern physics, is you look at something not of physical space, but something like a state space, a configuration space, something like that. If, of course, you assume that the fundamental theory will be a quantum theory, then maybe you have configuration space or a Hilbert space or something like that. That's going to be the fundamental sort of space. And in an approach, as a side note, called wave function monism sometimes, a particular way of understanding quantum mechanics, of course, that's exactly what you assume to be the fundamental space to be. It's the wave function, it's the fundamental object. It lives in configuration space. So configuration space is your fundamental space, not physical space. And maybe, this is exactly how you should approach that problem. You should think of configuration space as the fundamental space, and maybe the wave function then as the object that lives in it. And the possible ways in which the world can be is all the possible different wave functions you can have defined on the configuration space or something like that. So the idea more generally is to use another space such as as a foundation for the Humean supervenience space. Now, this is surely a very interesting proposal, I think, It's very promising, but again, I think there are some obvious problems that would need to be addressed if that were to be pursued. Here's just two problems, really, and then I conclude, I promise. The problem is, the first one is, it does seem to presuppose a rather specific space, but each system has its own state or Hilbert space. So if you have a Hilbert space for to describe, say, the spin state of an electron or something like this, and that presupposes, in some sense, that the world can be any way in which that spin state of the electron could be. It could be any element of the Hilbert space, say, could be a possible way the world is. But what about the worlds containing 2 electrons, or 3 electrons, or other stuff described by other things, and maybe other degrees of freedom rather than just the spin degrees of freedom of the electron, and so on and so forth. Now, to some extent, of course, you can address that concern by generalizing. You can say that, oh, of course, we could have different combinations, different Hilbert spaces of any kind of complexity, which are the possible ways the world could be, right? And then, of course, any element in it could be the state of that world, as it were. So that, so you could have a much more complexified pluriverse, if you want. Okay, but in any way, it seems like it's hard to get around, or you have to find an appropriate generalization, not to fall prey to the objection that what you're describing is a particular sort of system with a certain base properties already that you presuppose as the only way the world could be. So you have to be careful here, to be sufficiently general. And even if you successfully generalize it in this way, it doesn't seem to resolve a second problem, namely that it would still make free recombination somewhat hostage, I think, to a particular theory or families of theories, namely in some general sense to quantum theories in general. And you could then ask, say, like, well, but surely, if the fundamental theory is a quantum theory and you have some sort of structure like this that you presuppose, that's already part of the assumptions, the basic axioms of the theory that you accept now and that you use to construct the fundamental structure. So it seems like whatever the details are, whatever parts of physical theories you're going to use, as soon as you use some parts of a physical theory to do that, then you already introduce some, maybe mild, but nevertheless some form of necessity, because you rule out other combinations of things, structures that would not be consistent with those perhaps very mild assumptions that you're making, that you're accepting here. So in general, we could say that the tentative result that space-time disappears at the fundamental level would, if borne out, of course, force radical reconceptions of what it is to be a law of nature. So I've sketched some of the implications for the Humean approach. In the paper, we do sketch similar implications for both the dispositionalism and primitivism. So in a way, that's a general result that I haven't fully argued for. I completely understand this, but just to give you what the general conclusion is that we would like to arrive at in the paper. So this would be the case for all three approaches, as they presuppose fundamental space-time. It seems in the way in which they construct what the world is and how you're supposed to add in the laws and what they do seems to presuppose space-time. So it will have implications for any of those. And in fact, the required revisions seem to be so sweeping that it really is a question of whether these approaches would survive into the new era in which we do try to say what laws of nature are in a sort of a post-spatiotemporal world. More specifically, the implications of what I've shown today here for Humeanism are that the non-spatiotemporal physics, again, if borne out, and that is a rather big if, I understand, would deprive the Humean of a natural supervenience space on which to apply some form of free recombination to generate metaphysical possibilities which are devoid of necessary connections, which is really the heart, I think, of the Humean idea. If you violate that, it's very questionable that what you're doing is still a Humean approach. So this points, as I tried to illustrate, to a general tension that I find very intriguing and interesting, to be honest, between Humanism about laws and naturalism. And how can we navigate this tension such that we can still find some sort of way to glue together and say what the fundamental world is, what the particular facts are on which the laws are supposed to supervene, in a way that's sufficiently naturalistic and sufficiently Humean. Maybe Humanism and naturalism, you can't have the full extent of both. Maybe you have to compromise a little bit, but how can you somewhat negotiate that so that you can arrive at a stable place where it's still sufficiently naturalistic and sufficiently Humean? Of course, if you reject one of those, then this is not your problem. I completely understand that, and I find that tension only interesting to the extent to which I think that both naturalism and Humanism are attractive approaches to theoretical philosophy. But maybe this is just something that needs to be given up. Maybe this is impossible. We may not be able to look to scientific reasoning while suppressing how it projects in one form or another necessity or nomicity into the world. Now, this is not something I've argued for. This is just a personal sort of article of faith. I think that when push comes to shove, I think that Humanism is optional in the sense it would be a nice to have to understand the way the world is. It's an elegant, attractive way of thinking about fundamental metaphysics, but it's just that. And maybe the world isn't sufficiently nice that this will be possible. On the other hand, I think a naturalistic approach is mandatory. I see really very little merit in trying to give that up. So for me, when push comes to shove, my allegiance, I should say, is clear here. I thank you very much for your attention. So I've been a little bit over time, but I hope we still have time for discussion.
Yeah, it's fine. So yeah, whoever wants to ask, please raise your hand or write in the chat. Okay, Daniela.
So I have actually several questions, comments. So maybe the most relevant one is about this tension between naturalism and humanism. So I understand naturalism to be mostly a methodological principle. It has to do with in this understanding, it has to do with how we try to understand the world and our even at the metaphysical level. We try to sort of deduce or infer the correct metaphysics from the theories. So from the best theories we have. So from this point of view, I'm not sure I see really the tension with humanism, which is, again, for what I understand, an explanation or an account for how we come to get to those laws, to those which as encoded in theories. So it's naturalism is a bit in this understanding a way in which we try to understand better the content of the laws or the theories that encode them, which have in the humanist picture supervened on just matters of fact. And in the only sense in which one would have necessity in a law is is in the sense that we found some epistemic necessary relation between things as the best account for how things go, but not in the sense that there is some necessity out there. At least not necessarily. It would be a further step to say something like this. So from this point of view, I'm not sure I understand what the issue is. It would seem to me that we will simply try to look carefully at the laws that supervened on facts and check within those laws what is supposed to be the glue between matters of fact. Again, on the account of what the laws is telling us, or what the theory is telling us about the laws in the first place. So, in a sense, to interpret the result of this question, so we ask the law, or we ask the theory, what are these gluing conditions between facts? Then we get to an answer to then say, well, if we take this seriously, it means that they have to, because they come from the theory and the law expressed by the theory, they have to be somehow necessary in the world. It would seem to be basically falling back into some form of primitivism, as if the fact that they are expressed in the law amounts to the glue being out there as a necessary ingredient of the world, which I don't see what it would follow from. So maybe I'm just misunderstanding what the issue is, and I need some extra clarification. So let's say that that's what I'm asking for.
Mm-hmm. Okay, thank you. I'm not sure I fully understand the question on the other hand, but let me try to say again what I think the tension is. So what the issue is, okay, so as a Humean you want to say there are no necessary connections. That's a metaphysical claim. It's not an epistemic claim. It's really something that goes beyond that. Now, how is that supposed to somehow enter your metaphysical theory? Well, in Lewis, or a Lewisian approach, it's very clear. You say the fundamental ways a world can be, these, the occurrent particular facts or states of affairs. This is, in the statement on Humean supervenience, this is what Lewis tries to do. Fundamentally, the world is point particles arranged in space-time with different properties that they exemplify at those positions, or something like this. Or maybe, it's a bit more complicated than that, but something like that. And the way you then encode the idea of no necessary connections of Humeanism is to say that these connections, even though this particle decays into two particles at the distance of 5 meters from the other particle, which then decayed a second later into those particles or something like that, even though that's the case in your mosaic, right? The fact that this connection between the two decay events is not necessary is to say that they could have been at any other distance from one another. They could have occurred at any other time. They're freely recombinable in any way whatsoever. So you don't admit any, and they are freely recombinable in ways which would violate laws of nature. What we think, if we think that the laws of decaying particles like this they could be violated, and they could have decayed in combinations of particles which would not be permitted by the laws of nature, and so on and so forth. So that's the sense in which you have no necessary connections. Any of these possible recombinations, any combinatorial way of combining them is permissible in the sense that it's a metaphysical possibility. And the laws at each of these worlds, at each of these metaphysically distinct possible worlds, I should say it differently, distinct metaphysically possible worlds, at each one of them, the laws then supervene on the facts. at our world, we will find that, laws governing decays of particles will be such and such, and, those in this kind of decay will be permissible and the others will not be permissible, and so on and so forth. I mean, we do physics, right, by exploring a lot of particular states of affairs and events at our world and try to generalize and understand them in a theory. This is what we do in science. Now, the problem is, if I tell you now that the original characterization of what a world is like, any possible way a world could be like, is in a way not free of some sort of background theoretical assumptions. You presupposed space-time specifically. That seems to rule out some theories. And as a matter of fact, the point can be completely generalized. You presupposed that there are point particles, but what is it to be a point particle in the first place? What is it to be a field? Maybe, the point is very, very much generalizable. So any way in which you sort of characterize the fundamental way the world is seems to require at least some theoretical background. And if you're a naturalist, it requires some sort of physical, the way physical theories work, right? You want to be close to the physics. You can't just say any fairy tale. You stick to the way physical theories actually are formulated. And the worry then is that as soon as you do this, and even though you then say, and the way that, these kinematic possible states of affairs can be now recombined, can be such that they violate the dynamical laws, of course, and in that way you're going broader, wider than the theoretical, the theory at which you're maybe ultimately interested in. But nevertheless, you rule out many things because they don't conform to this statement or this way of articulating a kinematic possibility. And the worry then is that you're not, you're already assuming a maybe milder form of law of nature by assuming some sort of theoretical framework here.
I understand, but so
helpful.
now I understand much better. Thanks. But so it seems to me that the issue with the humanism is really not so much with naturalism, but with the pretense of being able to list possibilities without any theoretical framework. That would be somehow allowed to state what is possible as an abstract point without realizing that that's just cheating. I mean, I would ask Lewis. I mean, why would you choose point particles over and space-time over anything else? That's just the result of previous theoretical constructions over centuries.
Yes. No, absolutely. And it's interesting because as I myself embarked on that project, I realized that this, the more I thought about it, that this point is actually quite generalizable. And in fact, when you get to that point, you start to worry about, well, how could I describe at all what the particular facts are? I need to presuppose a human language and certain concepts and the way these things work, and in a very primitive and minimal way, without, forget about quantum gravity or fundamental physics. Just try to give me some account of these fundamental possibilities. Surely I must do that, right? Otherwise I cannot say anything. Otherwise I have to remain silent. So as soon as I try to speak up and articulate what I mean by the supervenience space, there is the worry there. So what I want to find, therefore, is, so that means that's the sense in which the complete full maximal of Humeanism, maximal extent, is some unreachable ideal, perhaps. So what we should strive for is we should accept that we need to make certain choices. We need to have some certain base background, pre-theory, some primitive form of that, that we allow ourselves too, without sort of incurring the charge that we're already violating Humeanism. If that's what it is to be Humean, to be completely free of anything like that, then I think Humanism is just an impossible thing. Then we're all non-Humeans. So clearly the bar has to be set lower. But now I think the interesting question that the question I'm really interested in is, okay, where do we find the sweet spot where we have enough background theory in some sense, or of a language of concepts and things, so that we can articulate our position in a sufficiently substantive way and in a way that's still Humean? Is there a particular, without imposing too much sort of background theory or any necessary connections that would come with it? And the worry is that I think this is perfectly justifiable in a sense of very pre-theoretical, pedestrian, non-fundamental physics kind of background theory. I think that's okay. But as soon as you move to physics, to a way to articulate what that basis is using fundamental physics or some general framework of fundamental physics, the worry then, I think, becomes more urgent. That's the worry, but, yeah.
I think that one should just embrace the fact that our thinking is always theory laden, and then just you accept it. It's a fact, and the only thing that will save you from putting too much into your conclusions that is too strongly dependent on a theory is how to say, holding too tightly to a specific theory, not being flexible enough to accept that tomorrow a new theory could come which is preferred, and you have to adapt your metaphysics and your starting points. And
yeah, no, I mean, I completely agree with you. That's my conclusion as well. But the specific question is, how far can you go here? If how much of a particular approach to quantum gravity would be acceptable as sort of the background framework in which you can help yourself to.
And before going to quantum gravity, sorry, you were asking what are possible choices for the glue. Did anybody propose the entanglement instead of space-time relations? That
yes.
could be more fundamental.
Yes, actually, absolutely, yes. There is a paper which is, written with something slightly different in mind by Rasmus, who has worked with the Geneva group for a while, and that's what he's proposing. Basically, I mean, not quite in those terms, but basically to understand or to replace spatiotemporal relations with entanglement relations, and this is definitely something that we will also list in the paper. Yes.
Okay, Federico, then.
Thank you for your talk. It was very interesting for me. I wanted to make a couple of questions. The first one is again a question of clarification about the tension you see between the naturalist and the Humean approach. I'm sorry to stress out this point, but I didn't really get why you think that on the naturalist methodological principle, we should have in our background theory, we should establish which kinematic configurations are possible. So I imagine, for example, a specific, I don't know, for example, maybe there is a specific kinematic configuration that in our world, in our, in the mosaic of the actual world, doesn't happen to occur, and therefore the laws of physics forbid the configuration insofar as they are determined by the mosaic. But maybe that kinematic possibility, that kinematic configuration happens to occur in another world. So the naturalist should just rely on what the laws of physics are, insofar as they are determined by the mosaic. So that's my first doubt. And the second one is if you can also clarify. I didn't really understand if you also think that the tension between naturalism and Humean is worse in the case of quantum gravity, and why is that? Thank you.
Okay, good. Let me try to address that. So if you can think of the difference between the kinematics and the dynamics, for instance, in causal set theory. In causal set theory, the basic kinematic structure that is postulated is that the world is fundamentally a causal set, which is a set of discrete basal events which are not otherwise distinguished from one another, so they don't have any intrinsic properties, and which stand in partial ordering, in a relation which partially orders them. And that relation is interpreted to be one of causal precedence. Any way in which this could be combined, any partial order, any discrete partial order is, in that sense, a kinematic model of causal set theory. Now you can say that, well, that seems, general enough, right? And in that sense, kind of innocent. And then what you do in causal set theory, you impose additional conditions, sort of dynamical conditions, as it were, and those which satisfy those additional conditions are then the dynamically possible or acceptable models. Now, the problem with this is that this is in a sense worse. I mean, not specifically maybe in quantum gravity than in other theories of physics, but this is problematic in the sense that you've certainly ruled out continuum structures. So, continuum relativistic spacetimes are not like that. They're not discrete structures like that, because they violate the discreteness assumption, the assumption that what's sort of causally squeezed into any two elements is a finite number of other fundamental elements. So that's another way of expressing discreteness. So continua are ruled out, and that doesn't seem to be quite harmless. So it seems like you're somehow saying, well, it's there's no necessary connections in the world, but this point here, space-time point or whatever you want to call this event here, necessarily cannot be part of a continuum structure.
Okay, yeah, I see the point.
Some sort of necessary connection that one might worry about and say, like, well,
Yeah, but then doesn't that depend also on the number of particulars that you have in the system? Because if you don't have the relations, if you look at the number of the elements that you have in the system, maybe they cannot form a continuum because they are not enough. Also, if they are infinite. So maybe that does not depend on the fact that you take off space and time from the from your background theory, but on how many elements you postulate, right?
Right. So I see. So you could say that, look, it's a fundamental truth that there are only innumerably many fundamental entities, say. And that has, I completely agree that this has a priori nothing to do with, space-time being fundamental or not, or anything like that. That's agreed. The problem again is, if I pick out any one of those elements, then I say, well, that has that element, that individual existing thing cannot undergo any necessary connections, except that necessarily it's not part of a non-denumerable infinity of events like it, say, or something like that, and that might already be considered a little bit problematic. I mean, look, as I think should be clear by now, there's some form of necessities like this that are going to come up no matter what language or framework you use to formulate your theories. But it seems like a very mild, sufficiently rich language and then a very mild assumptions about what the structure could be like should be acceptable without in any somewhat problematic way including necessary connections. But to distinguish the distinction of what it is to be a kinematically possible world in a physical theory or in some sort of family of physical theories seems already rather specific and therefore kind of strong, where it's probably, I wouldn't be so comfortable anymore in saying that there are no necessary connections there anymore. Right, that's the worry, and I think that worry, even though not different in principle from other contexts, seems to be particularly disturbing in context of quantum gravity, where you don't have any sort of fundamental space-time background anymore.
Okay, thank you. Thank you very much.
Daniela?
Yes, a couple of more specific points. So you mentioned that there's a possible substitute for space-time relations. Somebody has suggested to use the Hilbert space structure, so the fact that you have a space of states in a quantum theory as a substitute of configuration space. But that seems to be going the right direction, but in itself it cannot be the case because we know of inequivalent representations of quantum theories. So the same quantum system could be represented on different Hilbert spaces. So even for a given system, you would not really hang too much importance to a specific Hilbert space. In case one would have to promote this proposal to considering that the algebra of observables has to be the actual set of entities and relations that can provide the glue, which is the object that is defining the system before you choose how to represent it, and so would encompass different phases, different inequivalent representations. So that's one comment. And the second comment is that you were saying that the moment one uses a Hilbert space, and I guess they would apply also to the proposal in which one uses the algebra of observables, you seem to have a problem, because then you would have to choose a different one for each physical system. You will not have a universal sort of glue. But to me, it would seem that even the original Lewis proposal is exactly of this type, if not worse, because the space-time relations are in many ways just statements about a particular system being the gravitational field, according to general relativity and our more modern understanding of space-time, or at least the relation between the gravitational field and other physical systems in a more relational picture. So in any case, you will be given not only not only will be always referring to a specific system, but you will give some sort of preference or priority to one specific physical system to define the actual metaphysics of the world, which is pretty weird.
Yes, good. Yes, thank you very much for both of these points. I actually agree with both of them. You're quite right that Hilbert space, even though in some sense it goes in the right direction, I mean, if you want to find some sort of fundamental space in a way in the physics, you will have to navigate the problem of different representations of different Hilbert spaces and look at some sort of equivalence classes of those. And there are some, I mean, this is beyond my pay scale, but there are some ways of generalizing this, and maybe I mean, Laura Ritchie has written an entire book about, you know, that being problematic. So maybe that's really a flawed idea of trying to find a mathematical generalization of the fundamental replacement of Hilbert space. Sorry. And the second point is I very much agree that, of course, Lewis looks at a particular system and in a sort of a way presupposes that and takes that as a given, and then uses varieties or different versions of that to generate the pluriverse into different possibilities. And in a way, that's very much, if you come from quantum gravity, that's an almost obvious point to you. But for Lewis, that was not an obvious problem at all, because he thought, well, whatever there is, you know, like this Clark quote at the beginning, whatever there is, there's going to be, you know, stuff in space and time. And so that's going to be an unproblematic starting point. For him, it was a pre-theoretical starting point, a priori starting point, but it turns out that it's actually not theoretically innocent at all, because you built in quite a substantive, you know, assumption here. So meaning, in other words, necessarily, if that thing is a particular object that exists, it exists in space-time, for instance, or it relates, it occupies a space-time region or something like this. That's already presupposed. So in that sense, you also have necessary connections.
I will ask myself. So my intuition goes more or less against yours. So my intuition is that if I have to choose between humanism and naturalism, I would choose humanism, because it is because of facts in the world that I believe in the theories of science and whatever they predict. So if I have to choose between one of those, I would choose humanism. So then I was thinking that if that maybe we should reform humanism and say, okay, I believe in facts in the world. I'm not going to commit myself about whether they are spatiotemporal or in a causal set or in a wave function. But anyway, I want to commit myself with everything I believe. It will be based on whatever there is in the world. And maybe that would be a kind of answer some humanist would give.
So sorry, I'm not sure I understand I mean, I think I understand the point of view you're expressing. The question is then, so how do you start formulating, you know, giving some sort of meat to the bones of your Humeanism? Tell me more about what the world is like, or you know, how you think about the particular facts. What's that basis like? Tell me more. How do you do that?
Well, I need to start doing science and to start observing the world, to start forming an idea of how the world is, and then I guess that's like the iterative process of science.
So, but what what does the Humeanism then consist in exactly?
Well, I guess there will be some facts in the world, and us in some way observing them and forming our opinions about what the patterns are in the world. We will call these patterns laws, and maybe we believe there is a spacetime, maybe we believe there is a wave function, maybe we believe there is a causal set.
Mm-hmm. Mm-hmm. Yeah, maybe, but I'm a little bit worried that either your Humeanism is going to be so minimally specified what it is that it's hard to disagree with it at all. And as soon as you start to say more, then you become non-Humean in one way or another, or you introduce a form of naturalism. And when you do that, you may also introduce a form of non-Humanism then.
I can see that.
Yeah, I mean, that's the worry here, but it would be interesting to actually try and work out an approach like this.
Yeah, because
with the criticism that I've offered today in mind.
right, but so in your conclusion you said, oh, if we had to give up one of them, I would give up Humanism. And what reason would I have to believe in naturalism if it's not because of facts in the world?
No, I'm not against facts in the world. I'm just the idea that there can be some understanding of what these facts in the world are which is completely nomically innocent or modally innocent, that doesn't at any level introduce necessary connections, that may be an illusion. Now, maybe we're just really asking too much of a Humean. Maybe we can say, no, come on. I mean, let's not be ridiculous here. We have, we certainly can't help ourselves to laws of nature, right? That would be way too much. If I don't know, the Wheeler-DeWitt equation would be accepted as a fundamental part of whatever the world is like in any way in a Humean picture, it seems like, well, that's a pretty necessary connection. But maybe there is a reasonable way of doing that. But the thing is, I'm not so sure how to do that. And somebody would have to try and work this out in a bit more detail to see how far it can be taken.
Daniele, do you want to?
Yeah, just one comment. So this time I didn't even need to raise my hand. Thank you, Alvaro.
I saw you come in.
I'm just wondering if many of these difficulties come from insisting in some non-epistemic nature of the notion of law. The moment you accept that laws are just epistemic constructions, they're not out there. Then there's no conflict with naturalism in a sense. You have to stay within some naturalist attitude, because that's simply what you manage to do, and you rely on it to move forward. And many of these issues from this point of view are a bit how to say, they seem to me like indications that we are simply posing the wrong type of questions because we are starting from the wrong standpoint on laws and how we are supposed to approach these type of questions. And we are instantiating laws as if they were objects out there, and then we're just wondering about what is the relation with other entities, which are the facts. But facts could be complicated because there is the whole issue of perception and how we come with observations and so on, but that's maybe a complicated story. But laws to me, are naturally seen as epistemic constructions and tools, not as entities out there.
Mhm. Okay, good. So that's certainly also an approach to laws of nature that's actually been, important in the history of the debate. But it's not really those conceptions that I have in mind here when I draw this fundamental distinction between humanism and non-humanism, and it's not one of these, approaches that I've introduced. Of course, there are other uh, approaches, and some of them, in particular, if you don't want to be sort of realist about laws of nature, then you may not run into the kind of problems I describe here. So according to primitivism, it's the most straightforward thing. It really is a thing out there. It's part of the world. It's just there. It cannot be analyzed any further. So this is, what, say, for instance, Tim Maudlin says. That's his approach. Then the dispositionalists say that they're not really laws out there. What they really are dispositions. Whatever that is, fundamentally, there are dispositions, and laws are, if you want, derivative statements. You can formulate general truths that somewhat supervene on the dispositions these fundamental things have. But either way, you have a primitive modality that's really out there, and that's not just, and it's not a sort of an epistemic question of how of what we can know or what we know or how we do science or anything like that. That's supposed to be out there in the world. Now, for the best systems analysis, it is supposed to be modeled on the way we do science. But it's the idea that ideally, when we do science and we have, in the ideal limit, the best theory that summarizes or captures in a most general way, in the simplest way, most of that, the mosaic in our world, that would be the best system somehow. Those fundamental assumptions that go in there are the laws of nature, and they are really true at that world. This is not, it's not just a sort of a human, I should say, subjective kind of accomplishment. It's more than that. It's an objective truth at that world that such and such assumption of that best system is a law of nature. So it's somewhat ingrained in the patterns of the world, but it's really supposed to be out there. These are objective truths.
I understand. I think that my comment is, in a sense, was just that in this idealized limit, you lose track of what laws of nature really are, because you lose track of their, epistemic character, and you can pretend that they are objectively there, but in fact, I think that the moment you simply go to the better best system account of law, so then this epistemic character becomes much more obvious, and the idealization manifests itself for what it is, indeed, some idealization of what actually laws of nature are, even when you phrase them within some best system analysis. In the
Right.
better best system context by Craig and I don't remember who else.
Jonathan. Yes, Jonathan
Yeah.
Cohen.
Yeah.
Yes. No, yes, I agree, absolutely. And I think that kind of approach is maybe a promising way even to negotiate the tension I have then sketched. But I've addressed, not latter-day Lewisians or best systems analyses, just like the one by Callender and Cohen, but sort of the arch Humean, if you want, Lewis himself, and he certainly thinks these are objective truths about worlds. They're in that sense, these worlds are the laws are objective. They're that they don't, laws of nature are not epistemic in character. He certainly did not have that approach. Right, but when you come from the science, you maybe recognize that in some form what you do is trying to find the best balance between simplicity and strength, of course, but you would very much want to emphasize the epistemic nature of your endeavor, of your enterprise, and the provisional character it has, and so on and so forth. But this is not something that Lewis was interested in. Yeah.
Yeah, I have another question, but I don't want to take time to someone else. So, someone, okay, can I go ahead? Thanks. No, I was just thinking about while you were talking with Alvaro. You introduced causal set theory as one of these a possible substitute for telling us what is the glue between the particulars out there if we don't have spatiotemporal relations anymore. But then I was thinking, don't you need to, in the case of causal set theory, to assume that the events that are cause of other events are at least a necessary condition for the effect events to occur? Because if you, so I mean, after all, Humeanism in its origins derives from the idea that, you know, when the first ball hits the second ball and makes it move in a certain way, it is not that there is a necessary causal condition. It's just that it happens to be like that over and over time. So that's what makes me doubt that maybe if you take off the necessary if you establish that the cause is not a necessary condition for the effect to occur, then what is left of the causal relation? Thank you.
So they're not necessary conditions, excuse me, in the sense that, you know, this event here was not necessitated by this event here, say. It's a perfectly possible causal set, which is exactly like the one here, except that it does not contain this element here. So given that and everything to its causal past here, this event here is not necessitated.
Okay. So, but my question is, what
structure with this point or the structure without this point are perfectly possible causal sets.
Okay, but then what? So why do we call it causal?
Yeah. Okay.
That's my doubt.
Yeah, I would have to say probably a bit more for you to, you know, about this approach for you to satisfy about this, but it's supposed to be something like a discrete version of the causal structure of a relativistic space-time, or something at least not too far removed from it. It's motivated by a theorem in GR, which was formulated by Hawking and collaborators, and then Malamud in a more specific way, which said that if given the causal structure of a relativistic space-time, if it's sufficiently well behaved, it has to be past and future distinguishing. That's a specific technical condition of a space-time. But if it is past and future distinguishing, then the causal structure of a space-time will determine uniquely its its full metric up to a conformal factor. And a conformal factor is something like a factor of size that could of course be varied. That's not fixed by the causal structure alone, but everything else is fixed, and that's a remarkable statement. So the people who have developed causal set theory said, like, okay, maybe causal structure in a relativistic spacetime is really the key to what it is to be a relativistic spacetime. And they have asked, well, what is a causal relation like? What is a causal structure? And it's a partial order in some very generalized sense. And they said, well, and it should presumably be discrete because we expect the fundamental structure to be discrete. And so they said, like, okay, let's depart from this as our fundamental assumption, and let's try to see whether that theory will be rich enough and interesting enough to give us back something that might have the promise of a research program in quantum gravity. That's the idea, and that's why these are called causal relations, or maybe I'm a bit more precisely like causal precedence relations or something like that.
Okay.
It looks like you have a follow-up.
No, if I can help maybe to add something to what Chris said to Federico. So that you can think of those causal links in a causal set as just a discrete replacement of a similar statement in, I don't know, special relativity or any continuum space-time theory, and the statement would be event A is in the causal future of event B, or vice versa. That type of statement doesn't imply any necessity for one for the existence of the other. It just is a relational statement that tells you that something happening in B could potentially, possibly influence something happening in A, but there's no necessity there at any point. So a causal set is just a discrete version of the infinite continuity of statements like this encoded in any given space-time in GR, or in special relativity would be just a flat space-time, but in GR it would be more general. But so the list of all the internal, external to the light cone relations between pairs of events will be substituted by a discrete set of such relations, and that would be a causal set.
Yes.
Moreover, in quantum theory, you're also supposed to sum over those, so there is even less of a necessity in relating any two, because any two events a priori there could be an infinity of causal sets in between that you sum over.
Okay. Yeah, it's clear now. Thanks.
Yeah, great.
Is there any other question? If not, maybe we can leave it here. Let's thank our speaker again.
Well, thank you very much for having me. It was a pleasure, and I hope to get to meet you, in the not too distant future, actually in person.
Yeah, right. That would be great. Yeah.
Yeah.
Thank you, Chris. It was very nice.
Yeah.
All right, thank you. I will send the link because presumably I will receive the link for the recording. I'll send it to Sylvia.
Okay, that's great.
And then she can distribute it to the group.
All right.
All right, bye-bye. Thank you.